Welcome to assignment 29, the final part of our final project, the line following robot. You may have found our assignment in Schoology already. It basically has a link to the assignment document, a link to VEX V5 to help you get started with your coding, and this rubric. Why don't we go ahead and read through the document so that we have a good understanding of what our goal is here. So the assignment document just reminds us of how the line follower sensors are connected to the ports. If you've already completed assignment 27 and 28, you should be very familiar with this. This is just kind of a reminder in case you need to add your devices again. But I don't think you should. If you have already completed assignment 28, you can just pick up where you left off. Your task is to make a robot that can follow a line. In order to do that, we are going to combine elements from what I'm calling assignment 27 and 28, but they're the 6th and 7th projects we've been doing since we got to room 104. And this is going to help our robot follow a line. So we want to consider the order in which we're checking for things. So basically, we're going to look back at our code from our last 2 assignments and see, can we combine them so that the robot can follow a long black line. Note, your grade is going to depend on not just the group's grade, how the robot's doing. It's also going to depend on your own individual contributions. So please make sure that everyone in your group, both partners, should be contributing, maybe taking turns with the programming, maybe by debugging, maybe by calculating. Everyone should be helping. The max score for this project is 110. If you add all of these points up, I believe you're going to get something like 125. So think about how you want to mix and match these things because we're going to go up to 110. You must use the line tracking sensor. You must run from the start of the map to the end of the map without any assistance, any resetting, any nudging, any turning. You can't touch your robot while it's making progress. Also, you can have as many attempts as the class time permits. If your robot doesn't complete the map the first time, you can certainly try it again. Now for some helpful hints. If your robots, this is basically an outline of the program that you might want to make. It's really important that you read it carefully and really look for any keywords that might be in a bold font because that's going to help you find the blocks that you want to use. Let's read this together. If the right sensor sees the line, the robot rotates right while the right sensor detects that line. If the left sensor sees the line, the robot rotates left while the right sensor detects the line. Your robot drives forward only while the center sensor sees the line. You'll want your main code inside a forever loop. So those are some helpful hints. And again, there are some tips. You might want to consider turning left or right only 1 to 5 degrees at a time. These small turns are going to help your robot do a little bit of course correction as the line veers left or right, or maybe the robot gets a little bit off course. So we don't want any really big turns at any time. We're going to do a lot of small turns. You may want to stop your robot if certain detectors see a line. Something to think about. You may want your robot to move really slowly. That is something else to think about. I recommend that because your robot has a brain that can run its cycle of processing very quickly. So it can take those readings from the sensors extremely quickly. And I think if you want to have your motors at the same pace as your robot's brain, you'll probably want to have the brain pause sometimes between processing things, and as your robot moves slowly, that gives your brain time to take another reading and react to the next what should be the next movement. This one is also very helpful, I think. You might find a variable for your line reflexivity threshold to be helpful if you need to make changes. For example, set my variable to a certain value. Maybe we'll call it threshold. And then you want to make sure you're looking for a certain value under that threshold, and that would mean you're seeing the black line. So we're going to try that in our programming. So let's go back to the assignment document. If you click on this link here, it should open Vex V5 for you. And that is a great way to get started. You should already have code from your prior assignments 27 and 28. So I'm going to look at my assignment 28 code. I have that right here. And this was my code from assignment 27. I kind of put it on the side of the program. And this is what I added for assignment 28. So what I want to do now is think about how can I combine these two components to make one program that will follow the line. Well, one idea I have is I'm already checking for the right and the left. Maybe I can add another else if, where I'm checking if my center sensor is right over the line. So let me bring that in over here. And if it is, then I can drive forward. And then if it's not, then I'll stop driving. So everything seems to be here now. I really like that tip about having a variable that manages the threshold, because I might want to change this value as I test. So I'm going to go to the variables menu, and I'm going to make a variable called threshold. And I'm going to, I guess I better start by setting the threshold to a certain level. So the threshold is the point where we are no longer seeing white, we're seeing black. So what do you think is the value we should be checking for? Especially if we're checking for less than, if we're trying to look under that threshold to decide we are seeing a black line. So you might want to, I'm not going to tell you, I'm just going to go with what is the default right now, but you should probably play with that value as you test your robot. So now I can just have this value in 3 different places, and if I want to play with editing it, I can just edit that value in one place and play with what would be the best value. In addition, I want to make sure my robot is driving very slowly, correct? So how do I do that? I can go to my drivetrain, and I can choose to set the drive velocity to a very low number. I'm thinking single digits, maybe 5%, maybe less. And I'm also going to set my turn velocity to a low value. In addition, so you may find that you need to add a weight in each of your else or else if components, because this just helps the motors and the brain to sync up. Basically slows down the brain so that you can check once your motors have moved you into a new position rather than checking so constantly. So you might want to give this a try. And another suggestion, remember in our helpful hints, we have this series of ifs, which we pretty much have programmed, haven't we? But we don't have this while. The robot rotates right while the center sensor detects the line. While the right sensor detects the line. So if you wanted to add a while, how could you do that? Well, you could take this while loop, right? Put it here. Put these blocks in there. And we want to repeat this while we see the line. So you could certainly say, if I see the line, then while I'm still seeing that line, I want to make some little turns until basically we're not seeing the line anymore. So you might want to, if you think that you're set up well over here, you might want to replicate that in this section of your code and in this section of your code, such that you have added the wait and you've added the while loop. And give it a test. So good luck. Hopefully you are very successful and you can drive on all those paths and have a good time testing your robot. Good luck.